This is the Comet Borisov interstellar comet that was found in August of last year. And this is NASA image tracking ultraviolet images of the ice, the ice of the comet as it was passing the inner solar system. February, September, November, December 21st, January 14th, and it goes in a loop, as you can see. And this is NASA images. The Comet Borisov was found by an amateur astronomer who built his own telescope, a young man about 35 years old from Crimea. And Borisov, that's why the comet got its name, Borisov. It's an interstellar object. It's the second one in 2 years of an interstellar comet coming into our solar system. And the SWIFT mission tallied the water from that comet. As we know, comets have ice. Now, for the first time, NASA's Neil Gehrels Swift Observatory tracked the water loss from the interstellar comet as it was approaching and rounding the sun. The object 2I Borisov traveled through the solar system late 2019. Quote, Borisov does not fit neatly into any class of solar system comets, but it also does not stand out exceptionally from them. This is what Zach C. Zing, graduate student at the University of Hong Kong and Auburn University in Alabama, who led the research, says. He explains there are known comets that share at least one of its properties. Comets are frozen clumps of gases mixed with dust, often called dirty snowballs. Scientists estimate hundreds of billions of them may orbit the sun. Based on Borisov's speed and computed path, it must have come from outside our solar system. The comet is only the second known interstellar visitor, discovered 2 years after the first object named Huma Huma zipped through the solar system. Amateur astronomer Gennady Borisov discovered the comet August 30th, 4 months before it made its closest approach to the sun. The early identification gave multiple space and ground-based observatory time for detailed follow-up observations of this. In October, scientists using the Apache Point Observatory in Sunspot, New Mexico, detected the first hint of water from the comet. In the following months, NASA's Hubble telescope snapped images of Borisov as the comet sped along around 100,000 miles per hour. You can imagine how fast that is. It's a lot faster than asteroids that are about a third of that speed. As a comet approaches the sun, frozen material on its surface, such as carbon dioxide, warms and it begins converting to gas. And when it gets within 230 million miles or 370 million kilometers of the sun, water evaporizes. Zing and her colleagues confirmed the presence of water from Borisov and measured its fluctuations using ultraviolet light. When sunlight breaks apart water molecules, one of the fragments is hydroxyl, a molecule composed of one oxygen and one hydrogen atom. SWIFT detects the fingerprint of UV light emitted by hydroxyl using its ultraviolet optical telescope UVOT. Between September and February, Zing's team made 6 observations of Borisov with SWIFT. They saw a 50% increase in the amount of hydroxyl and therefore water Borisov produced between November 1st and December 1st, which was just 7 days from the comet's closest brush with our sun. The peak activity, Boris shed lights, 8 gallons, 30 liters of water per single second. 8 gallons per second, enough to fill a bathtub in 10 seconds. During this trip around the solar system, the comet lost nearly 61 million gallons, or 230 million liters of water, enough to fill over 92 Olympic-sized swimming pools. As it moved away from the sun, Borisov's water loss dropped off and did so more rapidly than any previous observed comet. Zing said this could have been caused by a variety of factors, including surface erosion, rotational change, and even fragmentation. In fact, data from Hubble and other observatories show that chunks of the comet broke off in late March. She said, "We're really happy that swift rapid response time and UV capabilities captured these water production rates." This is what the co-author, Dennis Bodwitz, explained. He's professor of physics at Auburn. He said, "For comets, we express the amount of other detected molecules as a ratio to the amount of water. It provides a very important context for other observations." Swift's water production measurements also helped the team calculate that Borisov's minimum size is just under half a mile, or 0.74 kilometers across. The team estimates at least 55% of Borisov's surface, an area roughly equivalent to half of Central Park, was actively shedding material when it was closest to the sun. That's at least 10 times the active area on most observed solar system comets. Borisov also differs from solar system comets in other aspects. For example, astronomers working with Hubble at the Atacama Large Submillimeter Array in Radio Telescope in Chile discovered Borisov produced the highest level of carbon monoxide ever seen from a comet at that distance from the sun. Borisov does have some traits in common with solar system comets, though. Its rise in water production as it approached the sun was similar to previously observed objects. Zing and her team also found that other molecules in Borisov's chemical inventory and their abundance are similar to homegrown comets from our solar system. For example, with respect to hydroxyl and cyanogen, the cyanide that we find even in the asteroid coming next near us now, tomorrow, the Apollo asteroid. Now, has a green tail and dust because of the cyanide. So this one here had cyanide as well. The hydroxyl and cyanogen, a compound composed of carbon and nitrogen. Borisov produced a small amount of diatomic carbon, a molecule made up of 2 carbon atoms, and amidogen, a molecule derived from ammonia. About 25% to 30% of all solar system comets share that trait. But Borisov's combined characteristics divide placement in any single known comet family. Scientists are still pondering what this means for comet development in other planetary systems. The team's results were published yesterday, April 27, 2020, issue of Astrophysical Journal Letters, and are available online. SWIFT was developed to study gamma ray bursts, the most luminous explosions in the universe, but for the last decade, Bodwitz has used it to learn more about comets as they traverse the solar system. Most UV light is absorbed by Earth's atmosphere, so scientists must look for hydroxyl signature from space. And because SWIFT has a flexible observing strategy and rapid reaction time, it can perform long-term monitoring of interesting new targets. The first 5 observations of Borisov were composed of UVOT snapshots taken over 12 hours, and the last was a series of images captured over 24 hours. Quote, "The team did not envision that the mission would contribute so much to our understanding of planetary science when it was being built." This is what SWIFT Principal Investigator S. Bradley Senko at NASA's Goddard Space Flight Center in Greenbelt, Maryland said. He said, "But it's a nice example of people coming up with creative and powerful ways to use the capabilities that are out there to do unexpected and exciting science." This is from NASA information, and it's on phys.org, and I'll leave links below for you for this. Thank you. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. and we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.